apply nest function, Cartesian product, determinant, do join, drop while, branch values, and by key. Now, I want to explain some of these because like do join and apply nest function, these are more useful in pivoting and SQL and stuff like that that can be applied to any array. I'll kind of touch upon it, but I'll pick Cartesian product as an example. That's a very interesting one. So here we have an array of two arrays inside, right? Basically, it is an array of 1 to 10, and the other array is 2 to 3. So Cartesian product will take these two arrays and will combine every element from each of those arrays. So it will take 1, 2, 1, 3, 2, 2, 2, 3, 2, 3, 2, 3, 3, and so forth for every combination of that. And you can even give even more combinations, and it'll give you every combination of these kind of, every pair of it or whatever you want to call it. And it can be as big as you want. It can give, and be like a much larger series here. You can see that it's a long thing. And this actually is in fact used for, if you remember, we had this idea of, let's say 3, 5. This is a single value for each of these parameters, but you could actually say 3.5 and 5.10 or something like that. Then it'll give you for every combination of 3, 5, 3, 6, 3, 7 up to 310, 4, 5, 4, 6, and so forth. So it'll find every combination of that. And that's actually, this does work using that Cartesian product function, but it's a very interesting function to use. So let's go into the next one, drop while. So basically there are a bunch of functions like drop while and so forth. Let me pull it up on Wiki. If you go to filter on condition, you'll see that there are quite a few functions like collect while, such that, collect, take while, drop while, and so forth. And the main thing to notice here is these sets collect while has a parallel collect while as vector, and such that is a vector, and so forth. So other than that, the thing to notice is that they all use the same underlying function called filter on condition, and it has these flags 0, 1, and 2, and for the versions as vector you have 10, 11, and 12. Essentially what it does is it'll take an array and it'll apply based on this condition, this number 0, 1, or 2. 0 means you collect it, and 2 means you drop it, and 0 or 1 means you collect it. You collect while something is true. So if you took like 1 to 10 and said dot collect x less than 3 or something like that, it'll collect all the ones where x is less than 3. But if you had something like 13, it'll pick up all of them. So it's like a way of applying, and I think you can also try collect while. It's the same thing. So here you're giving a function, and this could have been given like this also. Like you could have just said in a quote, and it would have done the same thing. Or z, like let's say 5 or something. X less than 5, give us all the numbers in here where x is less than 5. So the other one is branch and branch values. So branch values basically mean if you have like this, or let me put it this way, minus 10 to 10 branch values. Let's just do branch values and you'll see. So essentially what it does is it takes all the negative numbers and gives an array of them, and all the zeros and gives you another array, and all the positives and gives you another array. And if you said branch, it will not give you the values, but it will give you true, false for each of those conditions. It's basically saying that in the set of 21 array elements you had, if you're looking only for the negatives, this is the pattern, array mask, and this is the pattern for zeros, and this is the pattern for positives. And that's what branch and branch values are. And typically these are used for certain, masking and filtering and stuff on arrays. So they're very useful. If you know how to use it, it's very very powerful. And you can take a lot of numbers and say which one satisfied a condition and then just use it. That's the idea here.